So Cristina, want to start?
No, actually, we decided that Mihai will be.
Okay.
Actually, it's not Mihai, it's Mishu. He will start. So Mishu, the scene is yours. And then...
Yeah. Thanks, guys. Thanks for inviting us at the meeting. I am working at IBM Romania in Cluj. We are a team of 5 engineers here who are doing Watson machine learning services in Cluj. It's basically the core of the machine learning services for a lot of other services that are in IBM. What else? I'm the inside of this group. I'm the tech lead for the component that we call AutoAI, which I wanted to talk this meeting and show you a bit what it is. But beside this AutoAI, we are covering other machine learning topics in our group, like related with the deep learning technologies and so forth. But today, I wanna show you guys and talk a bit about the AutoAI part, what it is and what it is important for the IBM and what I think it is important, especially for the machine learning community. Yeah, that's pretty much what I wanted to tell Cristina about me.
Okay, let me quickly introduce myself as well, and then Mishu, it will be over to you for the live demo, because I think your bit will be the most interesting bit for today.
Okay.
I'm Cristina Morariu. I know some of the people in the call, which is really nice. I'm also working for IBM Romania in Cluj-Napoca. I'm actually part of another division compared to Mihai. Mihai is working for IBM as a product company on IBM products. I'm working for IBM on the services division, and I'm leading the Nestle account in Romania. We are around 80 people from Cluj, Bucharest, Sibiu, all over the country. And I wanted to have this introduction, more or less, to tell you about machine learning projects in delivery. So in production, not only theoretical stuff. And the funny fact is that myself and Eugen, well, we know each other from a previous company, from Subvision. And in Subvision, we were part of one machine learning community. Actually, we were the founding people of that community, part of Subvision. We both left Subvision since then, but I know that the community continued, and they actually have real projects in the machine learning stuff currently with different customers from United States. Before I tell you about Nestle and what we are doing for them, I want to ask you, just to make it a bit more interactive, do you guys work on machine learning stuff on a day-to-day basis, or is it more like a passion? You study by yourself, you have the opportunity to apply it? Any input?
Hi, I think I'm gonna break the ice. Can you hear me?
Georgia?
Yeah.
Great.
I'm George. I'm from Iași, and I'm on a research on machine learning. This is my first year on my PhD studies.
Excellent. Thank you.
And the area of machine learning that you said, IBM is not only for auto, and there are many domains. My area of research is machine learning for cybersecurity.
Very good. Machine learning.
Thank you. And now let the others break their eyes.
Let's take one more feedback from someone. Anyone wants to share? Well, we know, Mihai, you are doing machine learning, implementing the backend actually. Let me quickly share my screen, and then Mihai, you can take control when you do the demo. Of course, as a very good manager, I work with PowerPoint. So what we are doing, I'm trying to go a bit through what we are doing for Nestlé. Well, there is a partnership between IBM and Nestlé, and when I'm saying Nestlé, I'm talking about Nestlé as an umbrella on top of all the different brands that you guys for sure have heard of, from Nespresso, Dolce Gusto, Starbucks, and so on. And at the group level, at Nestlé level, we have this partnership, and the aim of the partnership is to implement different projects in the data space. It's called actually analytics service line. And when I'm saying analytics and when I'm saying data related projects, this covers everything from ETL, so extract, transform, load, handling the data, moving them across different databases, different clouds, and so on, to data visualization. And of course, the top of the ice is the machine learning projects that we do for them. In terms of how we are organized to make this work in delivery, not at the research level, we have different phases. So the projects usually are really small in terms of team size. It's 2 up to 6 people, not more than that. And the projects are very short. So we have projects that are 3 weeks. We have projects that are 3 months, but for sure, I didn't see so far any project that is 1 year. So these are small projects, very dynamic. You implement something and you move to the next one. And this is the reason why I asked this question. Machine learning projects have something, at least in when we are talking about production-ready machine learning, they are different. You cannot compare it to a Java project or to an e-commerce project. And the way that we set it up, this partnership between IBM and Nestlé, is considering different stages. So each project, and again, the customers in our side, on our side, are the different brands. The first project that we implemented was actually with Dolce Gusto from Korea. And there is a discovery phase when there is a data scientist from IBM working with the customer. As I was saying, as an example, this would be Dolce Gusto from Korea, to understand what data is available and what is the problem that we are trying to solve. After this phase, this discovery phase, we end up having well, a Jupyter notebook. In most of the cases, we use Python or R, depending on the flavor that the data scientist wants to use. There is no recommendation here. Each engineer is free to pick up his tools. And we end up training a model that will be sent to the business to be validated. And then if the model is validated, the project will go into the next phase, in which is no longer a pilot, but it's actually, we are preparing it to be a production-ready product. So then we talk about big data in some cases, we talk about Spark, we talk about Hadoop, we talk about all other things that are more, well, as I said, production-ready, not discovery and analysis, to call it like that. We have 5 main streams of projects in this space. Process analytics, and here mainly it is data visualization more than machine learning. So we are analyzing from a consumer product. So Nestlé, as you know, it's a consumer product. They buy materials and they produce coffee, chocolate, Pampers. I don't know if they have a Pampers brand or not, but they produce a lot of stuff. And this is source to pay. And then another important flow for each consumer in the company, it's order to cash, or if we talk about the people in the company, we talk about projects in the space of hire to retire. These are just three main areas. I wanted to give you an example of how our world is looking like this moment, what type of projects we have. Again, in the process analytics space, the majority of the projects that we see, at least until now, are in the data visualization space. Then another big area is digital and consumer analytics. Here we talk about customer segmentation or targeting. And the example of the project that I was mentioning with Dolce Gusto from Korea was actually a customer segmentation project. For you guys that are machine learning specialists, what we have done was to get the data that we received were data about the customers of Dolce Gusto from Korea and their buying habits. The outcome of the project was a model that we created the clusters. We evaluated the customers which are likely to stop using Dolce Gusto products in the near future. That was the first outcome. And then the second part of the project was to go with targeted loyalty campaigns to these customers to be able to keep them, to retain them as a customer of Dolce Gusto. As technology, as I mentioned here, for this specific project, we used Python and Jupyter notebooks. Nothing more than that, but it was funny, right? When we finished that project, it was Mishu and another guy from Cluj that presented AutoAI, and there was this debate. You do all this modeling, do you do it manually? Why should you do it automatically? And I'm very curious about your reactions when you will see what Mishu will present, because actually from a business perspective, it would remove this overhead of a data scientist. And well, not completely, but it will remove that effort that is needed from a data scientist to evaluate the different models. Going further, we have tailored business insights. Here we see projects. One example is fraud detection projects. We have different type of projects in this area. One fraud detection project, I'm not sure if there is someone from Nespresso, from the development team here in the call. In the past, we used third-party providers like Sift Science that train the model for us, and they are just sending us a score. But in this partnership now, we see more and more projects that are built from scratch, and we are actually the ones that are training the models to evaluate if a transaction is fraudulent or not, at least to have a rating. Then another big chunk of projects is in the marketing mix model. If there is anyone from marketing in the call, they would certainly recognize the domain because it's, well, this is something that is taught in university if you're studying marketing, and it actually tells you how it's actually predictive model that you need to build to understand. One example is if you pack together Pampers and beer, you will see, and this is the example as I understand from the book, so it's not something that I'm inventing right now, you will see the increase in sales for beer because the dads, when they go to buy Pampers in the middle of the night, they will buy a beer as well. Leaving the joke aside, marketing mix model talks about how to combine the products, how to order them on the shelves, and how to set up the prices to maximize the profit. And then we talk about demand planning, of course, as any well, company that deals with factories and with products. Forecasting is very important. it was even more important now during COVID. And I wanted to show you, I will actually show you a dashboard. Here in the demand planning, besides the forecasting that is done using different models, it's also very important to know, we see a lot of projects in the data visualization space as well. And we see, for example, during March, June, we implemented dashboards to show if certain factories are affected by COVID or not, meaning if they are in quarantine or if they continue to deliver. And this would allow a company that is producing goods to shift the different the demand on the different plants, on the different factories, to be able to have the products available as needed. What I forgot to mention, even if we are part of IBM, Nestle is actually, as a technology, they are a Microsoft shop. So they use Power BI for data visualization, and the entire stack in terms of big data that is provided by Azure, from data lakes, Databricks, Spark. So all these are consumed in Microsoft's cloud. With that being said, I want to ask you if there are any questions. Oh.
We can also use the chat board if it's more convenient.
Also, if you want to share, again, I imagine some of you are working on machine learning projects on your day-to-day job. No, it's not only a passion or something that you are reading about or are passionate about. So if you want to share anything, now is the moment. Otherwise, Mishu, I will let you continue with the beauty of AutoAI and what can it do for us.
Thank you, Cristina.
Yeah. Okay. So before telling you some things about AutoAI, I want to mention. Let me see. Okay. I wanted to say hi to my team in Toronto. I invited to this meeting the team there because Monica is the director of Watson ML. And she's from IAŠ, so yeah. I immediately thought about her when I got the invitation about presenting into the IAŠ AI, because she, as a director of the IBM Watson ML, I think she would be proud for this community. So hi guys there. Okay, talking a bit about AutoML, quite a different thing that Cristina spoke about. The fact that although we are in the same office in Cluj, we work in totally different products and totally different groups inside of the IBM, a very big company. I think we are totally separated by the things that we are doing. We inside of the Watson are doing a product that it is the core of the IBM services that are offered mostly to the customers that keep data inside of the IBM cloud. It is basically, if you are familiar with probably Azure or even better with Amazon services, one of our IBM competitors for keeping data in cloud and offering services, one of those being machine learning services, and particularly the AutoML service. Well, some words about AutoML. Well, it started, the AutoML idea, it's not very new. It started from a core product that IBM had into the research team, who were competed into the Kagglebot competition. Probably the communities are more familiar with the Kagglebot competition. Is one of the most emblematic machine learning competition. A lot of the companies gather different problems and offer for the whole public in order to do for their data that they offer to be trained a model, and whichever model score best, it gets a prize, and prizes are quite important in this area. Are you familiar with the Kagglebot competition?
I think we have some buttons here, like yes.
Oh, okay. Okay. Okay, just to give you, if you go to the Kagglebot sites, you will see the bunch of the competition. Just to list a couple of them. One of them was from an oncologic hospital in US, who offer like a couple of images of CT scans, and each image of the CT scan has a category. If it's a disease A, B, C, D, of course, all anonymous. Even the disease doesn't mean doesn't matter the name of them. And whoever managed to predict for the new CT scan which disease is based on what they learn into the from the previous images won. I think the price was like $1 million. So quite important things into the Kagglebot competition. So IBM had a team of data scientists who competed in this Kagglebot competition, in this Kaggle competition, and they created an automatic tool who can learn from a data it is analyzing, mostly on the classification problems and on the regressions problems, and they competed in this competition quite with success. What is exactly an AutoML tool? Well, if you guys ever work with trying to solve a machine learning problem, your first thing that you have to do with the data that you have is to train a model. Meaning you already have the data like a CSV or an Excel data where you know the fact that a person has a certain age, a certain number of children, and you try to predict, for instance, if I don't know how many children does he has based on a certain fact. And once you learn the data and you create a model, you then can use the model in order to predict for new persons or what is going to be actually the result of the target field, like how many children would they have. Various machine learning tools are available for this stuff, but when people use these kind of machine learning tools, they need to sit pretty much beside a data scientist, who is a mandatory person to sit there. And then most of the people, they need also a business analyst in order to tell what those fields are, what in terms of the marketing, what does it mean, things like that, which fields are important in order to be considered in the different models. And then the data scientist who knows all this math stuff in regards with if he has to do a linear regression or if he has to do some mathematical problems. And then with these tools, now you can imagine you have to go to the business owner, to the guys who are not that technical, and try to explain, look, if we do a linear regression with this data, we can predict with 80% accuracy if a thing will happen or not. If this new register that we get now, it's a fraud or not. And there seems to be quite a significant barrier between those very technical people, the data scientists, the things that they are talking, and the guys who do the business. Quite often this language, we see that it is quite a problem. What AutoML does is it say, okay, you just get the data into a server, whatever, CSV file, Excel file, no matter what, and you choose a column that you want to predict. And the AutoML will do all the parts, trying to figure out all kind of analysis between the correlations of a different features and the data that is inside there. And in the end, will automatically produce a model who said, okay, we managed to produce a model, and this model is 80% accuracy for the future data that you might come into to score with. The idea seems to be the people were very responsive to this thing, because now when you try in a normal business to do a model and to do machine learning, you don't need all that stack of scientists with their science language and all kind of machine learning terms in order to tell you what do you need to do or what is the outcome of their work. But instead, it will just produce a model, and it can tell you how accurate you are. That model can predict the outcome of the problem. So that's and when we went with this story and with kind of with what this AutoML solves to the customer, we got very, very good feedback, because then again, the barrier that we hit all the time trying to present a tool like SPSS Modeler, where you have to know how to transform the data, what to do with the features, what parameters you have to set for a linear regression and all kind of stuff. It all kind of melts, because pretty much everybody was then sounds to make sense that kind of story. Now, well, as Cristina suggested, well, that means the job that a data scientist and even a business analyst is doing with the data, trying to create a model which is useful to predict the future value, it's obsolete. Well, no. Probably most of the data scientists will also have a starting point trying to make better models. So you can just throw the data as it is into this tool, and as a data scientist, just look what kind of models the AutoML thinks it is the best model to make with. It will just say, okay, I can do a logistic regression or this kind of tree model with these parameters for this data, and could get a model with accuracy of 68%. It is a very, very good starting point also for the data scientist in order to know, okay, so how good my model was. Well, my model was better or was worse than this prediction. So quite useful also for the data scientist and for the business analyst. Also, all kind of other things like feature engineering, showing the importance of a certain predictor when you do a machine learning, like the revenue of the person. It is more important than I don't know, what kind of other field which is not important in the prediction of the spending or stuff like that. Well, of course, this example seems to be quite obvious, but it is not when you have 40 columns that comes into the model to see what factor is important for a certain behavior and for a certain model. Okay, I'm going to, if you have any questions so far.
I have one.
Mm-hmm.
You have been talking about linear regression, ordinal regression, and
Mm-hmm.
so on. Have you ever used structural equation modeling? Have you heard of it?
Well, we have a bunch of, I think, 40 type of models that our engineers continually adding into this AutoML. Basically, and that was the topic that I wanted to talk further. The advantage of having a tool like AutoML or a product like AutoML is that very rough. How are the things being done? You just get a certain type of model. Well, for simplicity, let's get linear regression. And let's say for linear regression, you can tune these 5 parameters. And those parameters could be in these values or could be in this range of values. Now, you start building a lot of linear regression models, of course, with the training data. After you separate the holdout data and all kind of things, or you can do cross-validation also, and start to evaluate how good the model is all the time. You tune the parameters, you change the parameters, and try to see how good this model is. After you're done with a lot of combination of linear regression, for instance, you move to the other model, like the one you said, and try to do models, tuning the parameters, optimize the parameters, and all the time doing the cross-validation to see what's the accuracy of the model. What the advantage of having an AutoML tool is that IBM created an infrastructure where engineers can throw inside all kinds of models. I mean, we have a list of the models that I'm not keeping up with right now because the data scientists keep throwing models from there. They are throwing models from different platforms, models that are in Python, models that are in Spark, models that are written in different languages and frameworks. As long as you keep building the models with the data and cross-validate the models, or you validate with the holdout data, you just have to measure, of course, for a chosen metric value, like root mean square error, for instance. You keep validating how good this model is, or the area under rock, how good the percentage is in determining if the person is going to survive or not, if things like that. But the idea is that you keep doing models and tune the models parameters. And the advantage is having a framework like this one is that you can constantly grow the types of the model, and actually you can come with new models. Well, they all boil into the same pattern. You do hyperparameter optimization. You do all kinds of models with a combination of parameters to see how the accuracy of the model evolves. And in the end, after a certain amount of time, you are saying to the user, well, we have a model which is right now, it passed 12 minutes since we started analyzing all kinds of models like this one. And we have a model which is 64%, but we still have another 1 million of combinations to be analyzed, and with another 45 types of the models to analyze and to orchestrate. And we will tell you again after 5 minutes which one is the best. And after 5 minutes, you said, okay, we find another model which is 75% accuracy, and we are still digging for new models with this one. Well, another advantage, I mean, another thing that boils very good with this strategy is the advantage of having a cloud. I mean, as you say, there are a very wide types of models. Now there is a, I don't know, Microsoft has an important library of their own type of the models. You can bring all of them together into the cloud. You can start 100 of machines doing models with different combination of parameters. Because this combinatory is so high, it takes a lot of time if you do it this one sequentially. So you pretty much need a cloud, not only for doing one model, but for doing all kind of automatic combination of the models to see which one is it's best. Yeah, we use the cloud infrastructure. So for that particular model type, no, I'm not aware of. We might already have it into the list of the when you do a classification or a regression or a time series. Time series is another thing that we are doing in the models. But the framework that we do at the Watson and then my team does, this framework for data scientists, allowing them, the data scientists from IBM, allowing them to throw inside of this framework all kind of models and formulas and lambdas that whatever qualifies to a model with the input features, to throw it into the AutoAI. And whenever a customer wants to do a model to see which model is best, this tool will get all the models and do all kind of parameters combinations based on some decisions that are making there to see which model is the best one. Because otherwise, it is pretty much what a data scientist probably do and with a business analyst on a day-to-day basis. You get some data and you are trying to build a model to see how good would you be able to predict the label, the target field, right? And you spend days, you spend months until you produce a model. The data scientist, the business analyst can help you saying, well, I know that we have 45 features, but some features are not quite important for this matter. Like in medical matters, I don't know, some things about person height is not very important about if the person will be immune to the COVID or not disease, but some other blood features, numbers are more important than the other ones. Because once you start doing this, once you prepare the data and you start doing a model, regardless of kind of model you do, you pretty much don't care if a column of numbers, it's some blood metric of that person, or it's I don't know, the height of the person, or you don't know in terms of medical or in terms of business if that feature is important or not. And pretty much AutoML try to come and not necessarily replace the data scientist and the business analyst, but more try to help him, because in the end, probably you as a data scientist, you are going to end attempting to do and failing to doing a lot of models in a whole in the journey for you to get a more accurate model, right? Yeah, if you have questions so far, more questions. So yeah, strictly asking to your questions. I don't know if we have that estimator, how we call it. Is that a framework in Python? It's most likely to have it, or is just or is just a lambda? It's just an algorithm.
Sorry, that was for me, I think.
Yeah,
yeah. So it's a sort of way of doing data analysis. I haven't used it in the logic of machine learning. This is why I asked the question. I'm sort of researching how you can bridge them, let's say. The idea is that you can create connections between characteristics, taking into account some previous logic.
Yeah, well, the way we choose mostly my team offer this framework, but the way we choose which algorithms should we use is so first it's for instance, it needs to be one of the types of the models that we do. It needs to do a scikit model if we get the Python in order to be fitted into this AutoML, which means you have to use a fit. Let's call it methods on an algorithm providing an input data frame and get a model for this one. And by a model means an entity who is able to score items that are on the same structure that the items that used to be trained by the models. I don't know. I've started. Yeah, I started with the idea that let me know if you want me to details things about model and scoring. Do you think that would be helpful to detail this kind of concepts, or they are well known in the AI? What do you think, guys?
So again, we can use the yes, no buttons in the participants panel if it is easier.
A yes for a detail, for more details, and a no for everything is clear.
Yep, something like that.
It would have been much more easier if we would.
Yeah. Okay. So yeah, we have yeah, people seems to know what a model and a score is. So yeah. Okay. Now, beside the technique of creating the model itself, I mean, lately, pretty much all the models are bounded into a pipeline transformation. I think, at least for the guys who are working on this field, on this area, you know that data preparation is also at least important than the model itself. So yes, the AutoML models are, of course, pipeline models, meaning the data can be clean or prepared before doing the models. One of the outcome of the model, which I think you probably are also very familiar, are the metrics of the model, because that's one of the most important things when we do a model, to know how accurate is the model. Is it a garbage? Do we better do random, or it is quite a formula that we can use in order to predict the data. And another thing that we have into AutoAI is as part of the feature engineering, we call this the feature importances, where we the scientist tries to explain for, I think, for each model, what is the importance of this feature, of each feature that took place into a model building. Yeah, what's the problem with this? So, I mean, what are the challenges when we create this AutoML framework? First is that the more models you bring and you invent and you get from the market, from the open source, and you try to throw them into this framework of whenever you have a problem of regression, that type of the model will be also built to see how accurate it is in comparison with the other models, is that it takes a lot of time to do thousands of models per each type, and I don't know if you can get for a regression, if you grow enough and have a very wide library of models to try to, like, probably get millions of models, you get a lot of combinations with all their parameters, each one, to do the model and validate it. Some of the techniques to do a model are fast, some not, but the problem comes first from, then again, the number of models that you have to build. And even if building a single model, it's not quite a time problem. When you build millions of models, could be a problem. Also, a lot of the companies have very large data and will attempt to do models with large data. Then again, could be a problem. It turned out to be that for most of the models, this challenge time, because is the biggest technical challenge that we have, of trying to fit and to build a model in a decent amount of time, and using a decent amount of resources also, is that the number of features that you have to fit the models impact a lot more, actually, than the number of items you have in the data. So the size of the data that we are used, like in the number of records, is not equally important than the number of features that you have for the models, in terms of trying to determine the best model. Well, if you would do this manually, like having, I don't know, for your data, 100 columns of data, will be obviously harder for you, but you also know that the complexity and the time taken to build a model could be higher than the one than the problem when you have few features but a lot of the items. What comes handy with this one, and that we are working on, is to bring, although we have it into the Watson, we don't have it into this AutoML project, is to try to bring GPU capabilities for doing the models. We have it for the deep learning algorithms. We don't have an AutoML models yet inside of the Watson ML for the deep learning. We have it for classification, we have it for regression and for the time series, but for the deep learning, for trees, and so we don't have this AutoML models. Probably doesn't boil very very good with this paradigm. Okay, before before jumping and showing you the, we do have neural networks. Yeah. Before jumping, show you the UI. I mean, what we do at the Watson is we do the backend services, which is pretty much in terms of microservices. I don't know how many of you are directly involved into the development of the microservices, or more like a software engineering than the data. But the same team developed this functionality as a microservices. Then again, on top of the cloud structure, which is mostly on Kubernetes, like it is for and the S3, like it is for pretty much standard into the clouds today. And various products inside of the IBM integrates or are clients for our microservices. One of our clients is the Watson Studio, which let me show you. If you have questions so far before showing you what I've been talking about. Then if not, let me share the screen. Do you see my screen now?
Yep.
Okay. This is a part of the Watson Studio. There are then again, for the data that the user keep inside of the IBM cloud, there are a bunch of tools and projects to analyze the data, to view all kind of stuff. One of the tools is what we call the AutoAI experiments. Unfortunately, I'm doing the demo on the development platform because although this is live, I don't know what accounts should I use on the production platform. So mind the fact that it is one of the testing platform that I'm doing. Let me create one from the beginning. Yeah, of course, you can, being a cloud, you can select the compute configuration, how many CPUs, how much memory you can use for this computation. In terms of the business models, this translates per time how much the customer probably is paying for these models that they are attempting to do on their data. Okay, I have here the test data that we are doing. We have, hopefully it's not real, the data from the persons who were on Titanic, and we want to predict how likely, when we see a model, if we can predict how likely is the person will survive based on what kind of what type of ticket did they have, what the gender, if they were I don't know, upper class, where the cabin was, on what level, and so forth like that, to see if it is predictable if the person is going to survive or not. In yeah, nothing really fancy, nothing really smart, I think here, but yeah, I think the data is also not.
Exactly as George is mentioning, is probably the most used data set.
Oh, okay, cool. Cool. Okay. For the regression, I have my own data sets. So I can choose if it's yeah, let me see the UI. I can choose manually what kind of data can be the features for this one. I can choose what kind of if it's going to be a holdout or a cross-validation. And I can choose what metrics I should be able to choose from the API. We can choose what kind of metrics do we choose here. I don't know what they mean by accuracy in the UI. Oh, okay, that means, okay. Usually choose area under ROC curve. Now, what's happened here probably not very related with the machine learning stuff, but if you are interested also how this is getting orchestrated into a cloud architecture, I can tell you. Are you interested or?
Yes.
Yeah, probably mostly for the software developers. So with the Kubernetes and with the type of the plan that the user select when he's creating this experiment, we raise a certain number of pods who contains these virtual machines with the Docker images that know how to do trainings of the models. And the Watson ML service orchestrates all these machines and monitors all the models that those machines does. What are the metrics of those models? Of course, the more machine you have to do the models, the faster it will create the models. Right now, in this pending situation, in this pending status, the cloud is starting up the machines. I say running, okay. The cloud was starting up the machine. We're raising up the Kubernetes machines that are start doing actually the models. So it is a phase of cloud orchestration of the infrastructure that is about to do the trainings. Data, it's being read by all machines who do the models, either cross-validation or validation with the holdouts. I don't know what has been chosen here into the backend. Yeah, some UI trying to tell the user in graphical things that some algorithms are being selected and some phases are being done. And you can see the first model has been built, and the the Watson is going to report, well, look, I built first the pipeline one, who turned out to be first one built XGBoost classifier, who has an accuracy of 82%. Then another one managed to make with other parameters another XGBoost classifier, who ranked first on top because it has a higher accuracy. Things are going to run for a while, and in the meantime, new models are going to be selected to be better and better models. Sorry. You can select at any point to save the model. The model is going to be again saved, and you can use this model at any time to score with this model. I think we have, in terms of the API, also a description of those models. I don't know if the UI of the description of these models or something like that. There are see curves or yeah, and some metrics. I think that the parameters for the models who have been chosen. It seems to be that it's quite important to survive or not. Agenda. Yeah, in the meantime, a better model has been selected. It seems that XGBoost classifier, it's a good model for this type of the problem. Of course, depending on the problems, you get better algorithms. Username pipelines, as I've told you, because probably, yeah, as you do some data transformation, also in order to clean up the data, to prepare the data. This has some enhancement of a feature engineering. I think it does some things with the features, probably removes the features that are not important, or does some derivation of the other fields that seems to be more important, and it does some combination of the most important field in order to derive new fields for the prediction, and tell you the accuracy. It shows here in a graphical way all kind of stages that it tries to do. This one split, I see the data using the split the data. I don't know why it says my apologies. That's validation. Now you have a random forest classifier here, also being qualified in a 5th position due to its accuracy. As a tool. And it will finish the stages. We used to have to be open to have a Python description of the models in the sense that you can snapshot in Python the model, and that translates to a notebook, a Jupyter notebook, with a pipeline code where you can reproduce this model again with all these parameters being set. I don't have it in this test environment. I don't know why, but seems to be pretty popular on the data scientists to get this model description in Python and tune it more manually, or I don't know, use it in their code, in their product, probably to tune their already existing pipelines where they fit models with. Yeah, a job that you probably as a data scientist might be familiar, like attempting different algorithms, did automatically weigh in order to produce models, ranked models with their accuracy, with all kind of features engineering. I think I hope the phase of this feature described also was the engineering of the phase. Like, I don't know, square root of the let me see, feature engineer, what's described. Feature transformation. Yeah, you see, it derives new features like this one. Like from the original feature fair, it did another transformation to build the model with, and this it's a new feature for the model, who seems to impact in the end the accuracy of the models. I don't know, to somewhat extent the data engineers who decide what kind of new features are being derived. I would be interesting to know from your experience, if you do feature engineering for your models. I mean, if you derive new models, and what's the path of deciding what feature you want to derive, and what's the best transformation for the feature, other than just doing the feature and see if you get a better model. Do you have this experience in your product? If not, I will take it as a no. Yeah, 8 models have been generated in different phases, but then again, the process itself did a couple of thousands of models, or hundreds of, probably thousands of models in this case, with all kind of algorithms that we have, and at some key points into the transformation before applying, before starting to derive new features for the model, it starts reporting, okay, so we have now a model which is this one with this accuracy and so forth. But thousands of models have been derived with, I don't know, for classification, about 40 types of algorithms we have. Seems to be that these two seems to be the better one in different phases. I don't know, the logistic regression or whatever didn't seems to be good enough to be qualified as good models, or at least AutoAI didn't find out for this Titanic to be better model than XGBoost classifier. Do you guys, I think these are all Python, these are all scikit model. The XGBoost, it's a, as far as I know, is a different library outside of the scikit. But the advantage of having a service like this one and the cloud is that you can create non-homogeneous models. Like, if all this one are Python models, if you have a framework that is written in Scala or in Java or in C++ that builds model in the, I don't know, PMML model, which is like the SPSS used to do, the AutoAI, it's capable of adapting and running different types of models, but the algorithm will have, of course, to fit with this paradigm of you fit the data into it, and you tune the parameters, you tune the features also if it's possible, and at the end it could produce a model that you can validate with a holdout or with a cross validation. If you have questions for me. Any kind of questions related with with all these estimators, with all these algorithms. I'm not extremely familiar with. I know some of them because we have a group of data scientists who just come up with new algorithms, even if they are algorithms, I don't know, from the open source or from the different frameworks, and they put them. And what we pretty much do, we orchestrate inside of this cloud all of these parameters, as long as they build a model that we can score with to see what are the metrics, what's the accuracy of those models. We trust the data scientists, so we just measure their algorithms with real data, either with cross validation, or after we split the data, we have the validation data, or with the holdout, in order to see if the models are good or not. We just put them in an AutoAI, and the AutoAI starts build whenever it has new data. It attempts the new models and algorithms that the data scientists come up with into this Watson suite.
Sure, I actually have a question.
Mm-hmm.
I add like a preference. I want a certain algorithm. I prefer that.
Mm-hmm.
And I run just that, just to see
yeah,
of that algorithm.
Yeah, that's a good one. You should be able to. I mean, into the API, we do. You can choose the algorithms. Yeah, I think we should be able to see. Let me see one. Okay. It should be prediction. Okay, what metrics should we rank the model with, which is a very important thing that I haven't talked about. And I think these are, for my testing account, the algorithms that you can choose. I'm not really sure if for the paid account there should be more. There should be one from Microsoft, which I don't see it here. So probably for the pay account, you have more algorithms to select to do this. What you don't have at this UI is you don't have the possibility to tune the parameters of each algorithms. Like, I don't know, take the alpha of this one between 1 and 10 with a step of 1, like 10 times of alphas. yeah, so there you can choose into the settings the algorithms that you want to be. I would assume it's bound by my testing account. You can choose then again the accuracy by which we should rank the model. You can choose here. We normally figure out based on the target column if it's a binary classification, if it's a discrete data or a continuous data. Then we put it as a regression. For a multi-class classification, if it has a couple of classes, we figure out it's a multi-class classification. If it has a continuous data, we figure out a regression, but nevertheless, the user can change it from here. Time series is pretty new. I'm surprised to see it here.
It is worth mentioning that you guys can play with this in the IBM Cloud. On the free account, you have access, as Mishu said, it's limited, but you can play with it if you want.
Yeah, you can play with it for a limited amount of time. For my IBM account, that submission expired a long time ago. But if your guys interested, or if you have a group or you can, I don't know, ping me, or I can try to see where's the production site where you can register and play with this into the IBM Watson Studio. So yeah, if there is a way to follow up with this meeting, I can probably.
Yes, for sure, Mihai. We will follow up afterwards, and I'll send a
okay
to everyone that attended.
Okay. Then again, you can play what columns you want to take part into model building. What is this? How data is being split. Yeah.
And I think, Mishu, I think you have some questions in the chat.
Oh, okay. Let me bring the chat somewhere. Chat. Where's the chat?
Next to the screen share.
Well, where's the Zoom?
Yeah, exactly.
I read them to you. So the first one is from George, and what you think that are the most common risks of using ML techniques?
Well, I mean, if we are not talking about the moral implication, using the machine, well, the thing is that the models know what they have been trained. So the risk here to attempt to score a data, even for a very accurate model, while the context of the new data has been changed, and the features who applied those changes are not into the same, were not part of training the models, then you will have a very wrong prediction for an assumingly very accurate model. I don't know if I was clear with this one. Let me give an example. You train a model for marketing data in order to see what is the most likely class into a multi-class classification the user is going to be part of. And you have all kind of the marketing features, I don't know, the salary, I don't know, the opening hours of kind of internet stuff like these ones. And then it comes, and then you have a model. And you have a model which is pretty accurate, meaning once you build a model with the input data and you have some holdout data to validate it, it turns out to be very accurate to estimate the data that you actually have into the holdout, and say, good, we have a very good model. And something changed, let's say as dramatically as COVID-19, and this COVID-19 was not a feature into your model, and you continue to predict with that model, although the context of the model had been changed. And strictly in this term of using the machine learning, I don't know, in terms of business, you turn out to use older models or inaccurate models because you didn't have the most important features who impact the change of the behavior of the model into the training of the model. Now, this is strictly talking about machine learning and models. Yeah, I think that's a problem that you can see. Now, of course, there are the classical one where you have biased data. We have some data preparation that should be able to handle these type of anomalies into the data. Like, I don't know, but also choosing them or looking at the metrics, you probably could figure out these anomalies. And if you want me to give another example with this anomaly, then again, it's pretty standard for the machine learning. You have persons taking the surveys and answering, which turn out to be a good model. And then you have missing data from the surveys, or probably that person get very bored on the survey and start putting abnormal values into the surveys, or just the system who collect the surveys introduces a missing data, the value of 0, while the normal range of the for certain columns is, I don't know, between 1 million or 2 millions. Let's say you have some blood measurements, and the normal value of a certain value of the blood property is between 10,000 and between 100 and 1,000. And then you have some missing values there where someone just put 0 because he didn't know what the value is or something like that. Now, when you do regression of the models, if you don't filter out these things, you will get a very biased model, a very inaccurate model when you try to score it with the holdout, and you won't know why. Probably for you as a data scientist, it is a common thing not to do. But I have to admit that in the beginning, when we jumped to the machine learning, we did a lot this mistake when we tried to validate the data. It turned out to be very inaccurate models because of this data who are not being cleaned. I couldn't stress enough how important it is to clean the input data, or else the anomalies from the data, the missing values, and so forth. We have a very important component into IBM who cleans the data, who replace the missing values with, I don't know, a mean or something like that, or just take out the rows who are incomplete or have anomalies, because this one is going to take part into the formula and pollute a lot the model. So you get a very inaccurate model. One other common mistake that I've seen, and that's not necessarily related with AutoAI, if I may, is that people do not measure the accuracy of their models. I mean, they just have to produce a model, so they choose one, and you just provide a model. And when I ask, how accurate is your model? I mean, what's the, I don't know, the accuracy, let's say in a binary classification, how accurate can you predict the they don't know, and that's a surprisingly very common mistake. You have to measure all the time your model to see how accurate it is. Either you do cross-validation or you keep part of the data that you have for training to not use. And then again, another mistake, being seen is that people measure the models with the same with the same data that they train the model with, which is seems to be terribly wrong for evaluating the model accuracy. Yeah, so I would put these three common problems and mistakes into the machine learning. The biased data, the data who is not who has anomalies, missing data or missing values who pollute the models a lot. The fact that people do not measure their models, or the fact that the people measure the models with the data that they train the model with. I don't know, probably could be stupid mistakes or sound, but yeah, they are what I saw.
And we had also some debate in the chat regarding forecasting models.
Chat, let me stop the sharing because I can see the. I don't know. Oh, I have it here. Cool. Yeah.
That's just I was asking if forecasting models can be trained. AutoML, AutoAI actually can it be used to train forecasting models? And George suggested to create a time series.
Yeah, we have the time series is under development. We didn't release it yet, I think. These days I'm working with the team in China who does the time series models, but algorithms to integrate them with the AutoML framework. But yeah, let me see this XGBoost. Yeah. Yeah, that's the risk if you do it right. I mean, the biggest risk is to do it wrong, but and with the problems that I've told. But then again, now speaking also about the risk and this risk of changing the estimators who are not included. We also have a project inside of the AutoAI. I think it hasn't been released. I don't know, which we call one button machine, who is a technique of aggregating multiple sources of data, and also a very important cleanup feature mechanism. It is for the pipeline. If you're familiar with like a transformation into that pipeline, a very important one.
Mishu, I also I didn't ask you guys until now. Do you have any invention patterns that are behind AutoAI?
If I do have personally,
you as a team, not you personally, but you guys as a developer team, did you patent anything?
I'm pretty sure the guys in Canada patent a lot of things in our behalf. Yes, we have a component who does data preparation. It's called ADP, which comes from automatically data preparation. Is one of the patents that we have. We have a patent that I forgot the name of, which we used into the Spark and Hadoop. I'm not using this anymore into the AutoML. So yeah, we have some patterns with joining big data, but that's not. Although Spark is part of the AutoML, we don't use that pattern in Spark because we join the data with other things. Yeah, time series we are integrating right now.
Well, there are some.
Yes, definitely. Yeah, definitely a very good statement. Yeah, yeah, I know. But in order to do this AutoML, people tend to choose the metrics, which they call the metrics for accuracy. I think it goes to be simpler put in words. So the people choose one metric, numeric, in order to rank the model. So by the accuracy, we means by which metric we rank the model. Although the term it's yeah, probably wider for machine learning. It seems to be simple than the metric. People tend to have problems denominating an exactly metric. So the accuracy seems to be fair enough. Just bear in mind that it is a tool who also target people who are not extremely technical into this one. And I think it was the biggest hit when we show these things to the people who just, I don't know, I mean, machine learning is not very new into the companies. When you go into a meeting with a data scientist with you, it is going to blow the meeting. You know, if it starts talking about math and about ROC and area under the curve and stuff like that, is going to blow the meeting. You have to have tools for the people who are into the business to help the business with the tools. So sometimes there is a strong debate and a strong game between the data scientists, the developers, the managers who want to put it like, can it be more clear for the user? Yeah, I probably, if you work on this area, you know what I mean. I mean, it's not a simple database operation where you get something from the database and you show the email to the user, and everybody knows that you get it from somewhere from a database and show it to the user. It's more, but it needs to be packed so that whoever needs to use it into a business case, guys, it's yeah, it needs to use it. Yeah, the advantage of having a framework like this one set up is that then you can easily drag data scientists with different algorithms that they write for, and just put it into this AutoAI competition of the models to see. It takes advantage also. I mean, the data scientists validate fast the models. The user take advantage that in eventuality you have an algorithm that really suits the user data. It will produce a model that the user can use.
And I don't think we have any other questions in the chat, but guys, if you want to ask anything else, well, you can also use the chat, use the unmute button.
Yeah, I know it's an AI group, but if you ask about, I mean, we created also the technology who orchestrates the machine learning into the cloud. So yeah, a bunch of microservices, Scala, Kubernetes. It's part of this infrastructure. Spark, of course, it's a big part. Spark clusters are part of this infrastructure. Some S3 storages is part of this infrastructure. What else? Microservices being written for different, with different Docker images running, some Python, some running Scala, probably some running R, I'm not sure. They are all servicing the purpose of building the models in their own way. If you want to ask about these things,
now is the moment.
now is the moment, yeah. Yeah. Anyway, yeah, feel free to drop me a note. I think you find me on LinkedIn. If there is other channels where you can find me, yeah, write me an email, or either way, LinkedIn is fine. Yeah, feel free to ask the questions anytime.
Cool. And because we are getting close to, well, it's getting late, and for the ones that have kids, it's getting, well, almost bedtime soon. We also wanted to talk about, well, I also wanted to talk a bit about quantum computing in the end, but I guess this will be like those TV series where we just throw a teaser now, and maybe Eugen, we group for another time to go into quantum computing in more detail and how can it be used in machine learning. Let me quickly share my screen because I also wanted to just in terms of a teaser, as Michel mentioned, you can play with AutoAI in IBM Cloud. In a very similar way, you can play with quantum technology in IBM Quantum Experience. It's available on the free account. So you have access, let me see, I've tried so you have access to different quantum computers across the globe. You can see here, one with 5 qubits is available in Santiago, Athens, 5 qubits, and it also shows, as you see, the pending jobs. So these are real quantum computers where you can run your code to see, the advantages, for example, compared to a traditional computing. Of course, after you learn quantum computing, if you do not know it already. But also you can, in Melbourne, as you can see, we have 15 qubits. I think this one is the largest. No, actually, yeah, we have 32 qubits in the simulator. But what I wanted to show, besides the fact that you can play with it in IBM Cloud, currently in IBM, there is, and not only in IBM, there is a big focus on quantum technology, not to be considered just for standalone. So we are not saying that by 2023, like we see in this roadmap, we will move everything that is machine learning from traditional computers to quantum computers. As IBM sees it, it will be a mixture of the two. Of course, for regular tasks and regular applications, we will still use traditional computers like we do today. But if we need to train a certain model, which takes a long time, we want to speed up certain activities, we can move that into quantum technology. Now, quantum computing is completely different compared to traditional computing, meaning that if, and I also prepared, well, in IBM, and again, we can review this next time when we meet, but just in case if you want to play with it a bit, in IBM Romania, we started a study group in quantum using this book from O'Reilly. It's called Programming Quantum Computers, and it's well, it gives you the basics of what you need to know without going into physics and into matrices and mathematics that, well, if you finished faculty 10 years ago, well, it takes a bit to remember Shor's algorithms or other mathematical stuff that you used to know, like in my case, for example. But yeah, it's very focused on hands-on experience. And what it's really nice about it, again, in our study group, we are using this book. What is really nice about it, let me see how I get my browser a bit lower too. Is that it has a simulator. So this is a simulator with a visual that can be really handy when you're learning something new. And this what I have here, it's a qubit. The qubit is a very basic and only 2 words about it. You can, well, the thing that makes it so powerful is the fact that you can encode much more information using a single qubit in its magnitude and in its phase. And it's, if we think about zeros and ones in the traditional computing, everything translates in quantum computing in probabilities. I will not spoil the fun. Maybe next time when we meet, we will go into more detail in quantum computing as well, and we will be able to see it in action in a machine learning problem, even if it is just in the simulator. As I was saying, this simulator is really nice. You can see from each state how your qubits are changing and how the phases are changing, how the magnitudes are changing. And last but not least, what I wanted to say, IBM has its own well, it's an open source language. I think it was around, it was in 2018, if I'm not mistaken, it was introduced. It's called Qiskit, and it's based on Python. So if you want to get really serious with quantum computing, this is, at least if you are planning to use the IBM Cloud, this is the way to go. And with that being said, I said that it will just be a teaser, and maybe we regroup at a later stage to go into more details. Eugen, over to you.
Yes, thank you. This looks very interesting, and definitely we will somewhere this year and talk about quantum computing. Now, Cristina, Mihai, thank you very much for accepting the invitation and sharing some insights of what you are doing with machine learning at IBM. And thank you all for attending the event. Hope you enjoyed it as much as I did. And also the recording will be available in the following days.
It was really nice. Thank you for having us.
Anytime. Thank you.
Thanks, guys. Bye-bye.
Bye-bye.